Hello and welcome to the channel. This is the first video I ever post online, so sorry for the shyness. Well, last evening I was playing a little bit with Arduino and DCS-Bios, and I managed to make something. What I did was I used an Arduino UNO board, a DC motor driver, and a DC motor to simulate the stall feeling. You know, when the aircraft cockpit starts shaking, well, that's when this DC motor starts spinning. I guess you can use this for multiple purposes like a kicker or something else. I don't know. Possibilities are endless. But I'm just gonna show you what I did and how you can get to the same result. From there on, you can just let your imagination guide you to something else, I guess. Before we dive into it, I'm gonna show you how the end result is gonna look. Right now, we're flying an A4E. This is a community mod. It's an awesome plane. So let's start a turn and let's get near a stall speed. I'm gonna ease on the throttle a little bit. And when the cockpit starts shaking, the engine, the small DC motor should start spooling up. And as we increase the pressure and we get closer to stall speed, it should spin even faster. Ooh, that's my very sophisticated device isn't working as well as I was hoping it would. Okay, so let's try that again. As you see, when the cockpit is shaking, DC motor is running as well. I'm gonna choose a wider view so you can see the stick as well. Okay, now let's try stalling the aircraft from level flight. Oh, we're descending already. It's shaking. I think we have the leading edge slats open, yeah. And we're stalling. Okay. Let's try it at high speeds as well. See if it works there as well. Should work because I tested it, but I want to show you because maybe this is not worth your time. Oh yeah, and by the way, this only works on the planes that are compatible with DCS-Bios. Lots of them, but we're gonna take a look in a second to which planes are compatible and which are not. Let's take a look at the speed. Okay, 500 knots. It's 450. Sorry, might be blind. 500. Okay, that's enough, I guess. So carpet's shaking, the engine spools up. Good enough for me, I guess. So, as I said earlier, we're gonna take a look at the list of aircraft. You can just Google it, DCS-Bios compatible aircraft, but here you can pause and see if you can spot the aircraft you want to have this feature on. I mean, you can have it on multiple planes. It's not just for one plane. I think it's gonna work for every plane in this list, but just, look through it. Okay, So the software we're gonna need, because we're gonna talk about software and hardware part. Software, we're gonna need DCS-Bios Hub. You're gonna find all the links in the description. After you've installed the DCS-Bios Hub, you're gonna open the web interface. If you don't have DCS-Bios icon here in the taskbar, you're gonna just open it from the start. Okay, and let's go through it a little bit. Let's set it up. So first things, we're gonna go to plugins. We're gonna go check for updates, and you'll probably find the modules you have installed on your computer and are compatible with DCS BIOS. Select them all, install them. If for some reason a few modules that you have do not appear here, it's okay, just open the plugin catalog and click on only show recommended plugins, and you'll see the rest of the plugins. Oh, okay, the next thing after you install the plugins is to go to the connection and make sure you check virtual cockpit. This is the one we're interested in. Try starting the game and load the plane that is compatible, so you have a module for. Go to dashboard and you should see virtual cockpit being green. If it's not green, maybe something happened along the way and you need to go to DCS connection again and just copy paste the text into export Lua. If it's green, all is good. Okay. We've checked virtual cockpit is working, DCS BIOS is communicating with the game. It's awesome. Next step is to download and install Arduino IDE. We just select the Windows installer, install it. After you've installed it, download the DCS BIOS Arduino library. It's zip. Do not unzip it, just leave it as it is. Remember where you've saved it. When you first start Arduino, it's gonna look something like this. First thing we're gonna do is go to Sketch, include library, and add zip library. Then navigate to the place you saved your DCS-BIOS library and click on install and install it. After you've installed it, you need to restart the Arduino IDE because it needs to load the library. Then when you click on file and examples, you're gonna find DCS-BIOS here. I have lots of libraries because I downloaded a big pack of them. You're probably just gonna have DCS-BIOS or maybe another one, I don't know. If you see DCS-BIOS here, it's all good. You have everything you need. Okay, next step is to see how our setup works. This is how I connected my DC motor to the Arduino. So this is a driver board. You're gonna find a link, and I think I'll put an Amazon link. I don't know, probably. I'll see when I edit this video. So this is L9110 motor driver. It's pretty good for this kind of motor. Lets you control the speed and the direction, but we only need speed because we don't care about direction, which way our motor turns. We just don't care. We only need to modulate speed. This is a 5-volt charger. You can just buy one for this particular setup, or you can do like I did. I just hacked an old USB mini port, I think it was USB, yeah, some old cable, and I used the red and black wire to hook up the driver board. So just go with positive, go to the VCC, and with the negative to the ground. And then with the A1 pin, you see you have here A1, B1, just choose A1 or B1, doesn't matter which one of those, and connected to pin number 3, and of course ground connected to the board as well as to a 5-volt supply. Simple, that's it. It's gonna look something like, well, I'm hoping it's gonna look better than this. This is my breadboard. These two wires are from the power supply. I also have a screen here, an LCD. It's a 2004. I use it for debugging purposes, and a switch because sometimes the motor gets weird when I first start the Arduino, and it's messy here on the, on the table, and I just use the switch to turn it off, I guess. Now it's on. But it is pretty simple. I'm sure you're gonna do just fine. Well, we're done with the hardware part of things. Now let's use the Arduino IDE software a little bit. I'm a noob in this, so if I'm wrong, just correct me. I'll try to pin your comments. I'm sure I'll get some stuff wrong, so yeah. Okay, let's first take a look at the Arduino board. You should connect the uh, cable, the wire that goes to the driver, just in the pins marked as pulse width modulation, PWM. It's marked with this sign, it's a tilde, I think it's called. So only pins 3, 5, 6, 9, 10, 11 are capable of this kind of signal. So mine's connected to pin number 3. If you're new to Arduino, it has two main functions: it's the setup and a loop function. The setup function will only be read once at the beginning, and loop function will be read continuously and executed continuously. So it means you have like uh, let's say statement 1, statement 2, and here 3 and 4. We'll read 1, 2, just one time, and 3, 4, nothing here, go back 3, 4, go back 3, 4, just at the beginning again. That's how Arduino works, or at least the how I think it works. Okay, we're gonna write pin mode. Be careful because this Arduino software is case sensitive as any C++ or C#, whatever program. So pin mode 3 output. So we've just declared that pin 3 is used for output. And let's start working with it. Analog. Let's start working with it. Analog write pin 3. The values we can enter here are from 0 to 255. Let's go 180, I guess. Should be okay. And we're gonna upload it to our Arduino. But before we upload it, we need to check that our port is properly selected. And we have selected our Arduino board. If you have issues concerning the COM port, you should probably just go to Device Manager and look on ports. This is a Chinese copy of Arduino, that's why it says CH340. If it would have been a genuine Arduino, it would have been Arduino something. But for me, it's kind of expensive, so I have this Chinese clone instead. Okay, let's upload it. You can download the Chinese drivers from anywhere on the internet. I'll probably leave a link in the description though. Okay, so output is good. Let's see what 180 does to our motor. So it spins, not very fast, but it spins. So we're trying to fine tune the point at which our motor starts spinning, our DC motor starts spinning. I've seen some tutorials online for this, and values usually go from 0 to 255 because it's 256 values, but you start counting from 0. 0 being no RPM, and 255 being maximum RPM. But for some reason, probably I did something wrong. From my setup, 0 is full RPM, so max RPM, and 197, 200 is the point at which the engine barely turns. We're going to find that point, so if for you it's the other way around, just remember the point when the engine barely starts turning. So let's go. Yeah, I keep saying engine because I'm translating in my head from my language to English, and my language is engine, I guess. Okay, uh, let's go 0 because yeah, I just want to show you how it works for me at max RPM. Okay, and let's go 195. Yeah, you see it barely turns. Okay, let's see if it turns if we put it at an angle. Yeah, barely. So I think this does it for me. So 195, just remember the number uh, at which your motor starts turning, because we're gonna need that range from maximum to low to RPM. We're done with the Arduino stuff. Well, I guess if you want to be pedantic, you can write motor pin and say it's equal to pin number 3 and just replace 3 with motor pin. But if you want to do that, you can do it. I don't care about those. I really don't mind just going with simple numbers because there's not that many and I can keep track of them. Okay, I'm just gonna turn off the motor because we don't need it running for now. And just switch to the DCS-Bios part of things. We're gonna go to File, Examples first, and we're gonna go to DCS-Bios and Default Serial. Okay. Then, in order to make this happen, we're gonna need to test it, see if the board communicates with uh, DCS-Bios and that DCS-Bios communicates with the game as well. So we're gonna go to DCS-Bios and uh, we're having DCS in background running. Our virtual cockpit is green. And we're gonna go to control reference. Control reference is the place where you find all your bits of code for different things, different controls of the aircraft. These are the planes I have, and I'm gonna show you how it works on the A4 because it's a free plane and everyone can have it, and it's easier for me to do it that way. But of course, you can choose your own aircraft. Let's go to accelerometer. And just from simple, not max, not minimum, just accelerometer. Integer buffer, just copy this with clipboard and paste it into your Arduino. We see now we have here a new value. Well, this new value corresponds to the value written here. If we have everything connected properly, when we go back into our DCS game, you're gonna see numbers appearing here. Okay, so the new value here is this value. Right now it's at 41,000. The range for this value is from 0, just gonna write it here, range is from 0 to 65535. That's the range for this value. Oh, hold on, let me hook up my joystick, is apparently it fell. The connection suffered some damage. Okay, now let's take a closer look to our accelerometer, because I'm trying to teach you how you can model stuff the way you want to. Go there. Damn it. We're just gonna try and take a good look at the accelerometer, and also try to keep an eye out on the accelerometer value and DCS-Bios. So let's say we want to go at 0 G's, see what value we have. So that's about 0 G's, so we have 32,000. Well, if you split 65,535 into half, you get a value close to this, is 32,767.5. Well, that's equal to 0 G's, and then we have positive 10 and minus 5, because that's a place where our gauge goes. Those are the values. So here is 10 and here is minus 5. I made an Excel sheet to explain better to you, to explain what I'm doing. So from 0 to minus 5, for each G there's 6,000 difference, and from 0 to 10 it's 3,276 difference, because this number gets divided by 10. As I said earlier, we're just gonna try and see if our setup works first. Let's just go to default serial and just pick a number. Okay, we're gonna go back to the game. Let's say 3. Okay, so 3 G's, it's about 42,420. And we're just gonna go if new value is bigger than 42420, Then analog right pin 3 with let's say 180. For me that's enough. Else, because we also need to make the motor stop if it's a value below that one. Else another right 3, and for me it's 255. For you, as I said earlier, you gotta check it. Maybe it's 0 because I might have plugged something wrong. Okay, and DCS connections. If your Arduino is already corrected, just make sure it's not anymore. Okay, so we've uploaded it. Just let's connect it to DCS-Bios. I'm gonna turn on. Okay, so we're below 3 Gs. Now we're above 3 Gs, and we see the engine moving. So it means we got it wired correctly and it's working. Awesome. Next thing we're gonna do is use some math and some formulas. I'm an expert painter, or not. I wrote some formulas here for you. So the stall speed in a turn is equal to stall speed for level flight multiplied by the square root of nz, which is g's. So if we would be at level flight, this stall speed will be equal in a turn. Well, so with 1g, our stall speed is exactly stall speed. At 2g's, this increases because we multiplied the stall speed with the square root of g's we're pulling. 138, I found this value on the internet for the A4E. I guess it's not really 138. We'll see along the way. Now let's head on over to Excel. What I have here is the G's, and for each value the speed at which you stall. So for 1 G's it's 138. I wrote 140 because I wanted to round it up. At 2 G's you can't pull more than 197 knots, and so on. So this just get a formula is just equal to stall speed or the square root of the G's you're pulling. Up until 10 G's. So if you're going slower than 442, you won't be able to pull 10 G's. Maybe my math is wrong, or some. If my math is wrong, just let me know. But I think it's okay-ish for what we're trying to do. Here on this panel, we've got some coefficients. Actually, this is just the first column, but I copied here so we can compare numbers easier. And here's a coefficient of 1.2. So I multiplied the values we got to a coefficient of 1 plus of 1.2 because I wanted to have a warning before the aircraft stalls. The start of the shaking, let's say it's here, it's 168, and complete stall is at 140. So we can see here I made a small chart, and below, if your speed is below the blue line at a specific G's, it means you have stalled. In between, the aircraft starts shaking, I guess. Well, 1.2 is kind of a big number. It's not very reasonable, because at higher speeds we're gonna go almost 80 knots. So that's not very realistic. I suggest you put here 1.07 maybe. So it's not that big of a difference. And it should be the same as you see it on screen when your cockpit starts vibrating. Of course, you can just go low speed and just add 20 knots, 30 knots, or whatever you want here. A thing like this only works if uh, on your accelerometer indicator the numbers are evenly spaced. And I'm going to show you what I mean. It's the same distance from 0 to 1 as it's from -4 to -5, or from 9 to 10. If you look at the speedometer though, we see from 80 to 100 knots is a different section of a circle than what you have from 400 to 500 knots. So here just 20 knots, here is like 100 knots. You're gonna have to take this into account, and you're gonna probably have to divide it in sectors when you're trying to build different setups, or if your accelerometer in this particular case has numbers which are not evenly spaced throughout. You're gonna probably try something like this with the sectors, and yeah, here. This is what I did for speed, one of my older projects. Okay, let's get back on track. So we've got these values, okay. We've got a formula. Now let's apply this formula inside DCS. First, we're gonna disconnect DCS-Bios, and we're gonna go to Arduino. We're gonna have side by side a program I made earlier, and we're just gonna delete what we already wrote, so we don't need it anymore. I'll probably just gonna copy paste this into the description so you can just copy it. Just don't pay attention to liquid crystal or wire.h, because these are for displaying stuff on the LCD screen. Maybe just include math. So we're gonna do just that. This is a math library. Okay, we will be needing the speed value, and we can get that from our control reference in common data. Just choose speed and go for this one. I don't know, for some reason this doesn't seem to work. When I tested it on the LCD screen, it always, even though here it would show a value, on the LCD it would be just a random value, not even related to that range. So just use this one, and we're gonna do just that. I could just explain it to you, but I'm choosing to copy paste it and explain along the way. So if a new value is uh, lower than 730, why lower than 730? Because I seen on the LCD screen that sometimes it spikes for like half a second, maybe it's an error or something. It spikes, and we don't need that. Also, we're gonna write, we're gonna define a global value. Okay, let's just see for a second how it looks. Yeah, so if you see here, we have nothing. Here we have 420, which is kind of bang on. Sorry for blabbering and for maybe being inconsistent. Um, that's just me. Okay, next I'm gonna copy paste this here, and we're gonna talk about it a little bit. So for the G's you pull, we're gonna map the new value from 1G to 65,535 value, which would be 10 G's. Let's take a look on the control reference because I want to be clear why we do that. Okay. Because I for once only want to have that shaking when I'm pulling positive G's, and probably could make it for negative G's as well, but I'm not interested in that. So why we have here 100 and 1000 instead of 1 and 10? First, let's take a look of how map value works. I'm just gonna write here an example. So test, let's say it's equal to map value to map from low from high to low to high. So it's gonna take a value you want to map, in our case new value, and it's gonna go from the low part of new value to the high part of new value. And it's gonna map to the low and to the high. And as an example, let's just replace these values. Let's go with let's say this will be 1, this will be 100, this is gonna be 1, and this is gonna be 10. So we're on new value. So if our value to map would be 50, the result would be 5, 30, and we get result of 3. If we say from 1 to 1000, and we choose, let's say 20, that would be a 0.2. But you can't have, because this is an integer, you can only have numbers that are not floating points, so no decimal. We'll have 1, okay, but we could also have 35, still 1. That's why we're going from 100 to 1000. We want to have those details. If we would just go from 1 to 10, we will only have values for 1G, 2G, 3G. If we have 1.1 Gs, nothing would happen. 2.25 Gs, nothing would happen. This is why I chose to map too low and too high for these particular numbers. I chose 158 because testing it, I saw 158 is a better speed than 138, and here I go 0.95 because I want a bigger gap. Of course, should have been 1 here because you stall, you can stall a little bit less, but works for me. If you want to get really professional, I guess you should just write here 1. Okay, let's go further. So the motor speed will be a map function of the current speed. So we'll have our current speed. Let's say if our current speed is 200 knots. Let's say our speed will be 200 knots. Then will be between these two values if we would pull 2Gs, because our current speed will be between the low coefficient, because the 2Gs were stall speed is 197, so we're above it at 200 knots, but below the high coefficient, which is 1.05. That's what I work with, and that's 211 knots. So in this particular case, when we have 200 knots, we'll be closer to 200. The engine will speed up a little bit faster with maximum speed at 197 or so. It would start spinning only when the speed goes below 211 for 2Gs. I hope I made myself clear of how this map function works. And here we have 0, which is maximum for me, maybe for you not, and you have to switch these numbers around. And 190, because 190 is the value for which my DC motor barely starts spinning. So when you have high 211 for 2Gs and current speed, the motor barely starts turning, the cockpit barely starts shaking. But as we approach 197, which is a low coefficient, then RPMs increase because we go from 190, 170, 1 and so on, and we go to maximum RPM. And below this, it just spins at maximum. And this is the code to do just that. Okay, we're almost done, just a few lines left. If current speed is lower than the low coefficient, means we have already stalled, because we have a speed lower than the minimum stall speed. And then we're just gonna write for the motor go maximum RPM. If our current speed is higher than the high coefficient, means we're not into that stall buffet speed, so just write 0 to the motor. Else if we don't need this, else if I was using this for testing purposes. Else meaning when we're in between these values, just analog writes pin 3 the motor speed. And that's about it. You also see here digital write pin 13 high. Pin 13 is the built-in LED of the Arduino board, is this pin right here. I was doing this to check if the motor should be spinning or not. So when the light goes on and this current speed is lower than the low coefficient, means you're stalling, so also the light should be on, else the light should be off, except when the speed is between the low and high coefficient, in which case should also light up. So let's write this to our Arduino. Make sure we disconnect first from the connection. Yeah, we're disconnected. Let's see if what we did works. Okay, let's open up the let's open up the game. It doesn't work because I have forgotten to connect the Arduino. Happens quite a lot. See, it starts spinning. Whoa, that was fast. Okay, let's go a little bit slower so it'll be easier for me to show you. See, the cockpit starts trembling, the motor starts spinning. No matter the speed, because we're always in that range. So we could go 500 knots, we could go 150 knots. The thing will only turn when we are approaching that stall speed. Okay, so this was my explanation, the best I could do. Sorry for being just this. Yeah, and with setup, we should have probably wrote pin mode 3 output, but as we've seen, it works without that. So we're good. We escaped. Probably some of you will find better solutions to this, and I welcome them in the comments. Thanks for watching. If you have reached the end, I guess thank you for your patience, and hopefully you've learned something. Now, take care and have a safe flight. See ya.